Let f be defined by f of x is 2x plus 3 over x minus 1. We want to find the range of this function using algebra only. We can use the calculator and find all we need, but we want to learn how to find the range. Okay, it's good to see how you can bracket the values that you need. Okay, but the first thing that we need to do here is that we can find the domain. So here we have a fraction. We don't want to divide by 0, and therefore we must have x minus 1 different from 0. Okay, and that means x minus 1 different from 0, that means x is different from 1. So when x is 1, we have a problem. That's why we have to get rid of it. So the domain is minus infinity 1 union 1 plus infinity. This means that in the line we have 1 here, so we come in from minus infinity to 1, we jump 1 from the left, and after that we jump to 1 from the right. It's like removing 1. That's what we mean. So here and here. So that's meaning that the set of all real numbers minus 1. Okay, so it's 1 only that we get rid of. Okay, now assuming that we can rewrite this function in a different manner, so let's do it. F of x is 2x if we subtract 2 and add 2. Okay, notice what's gonna happen. So on the top here we're gonna have 2 times x minus 1 plus 5, and we divide everything by x minus 1, so we have 2 plus 5 over x minus 1. Okay, so now we see something familiar. It's this function 1 over x, okay, that was shifted by 1 to the right. Okay, so here we can find the limit. So we see different limits here. Okay, so let's see what we can do. So here the limit, as x get bigger, so here you divide 5 by a bigger number, you get 0. So what's left? 2. When x gets bigger but negatively, the same thing, 5 over something big negatively, it's 0, so we still have 2. Okay, so that means we get close to 2 when x gets bigger, either from the big numbers or the negative numbers, the big negative numbers. Okay, now this one is going to help us because we think of this one. So let's say y is 2. So the graph of the function, it's either, in fact, it's going to be like this. Okay, and this is 1 because we don't want to have x equals 1. So when x equals 1, it's not defined. Okay, so that's the problem that we have. Okay, and also it's the function here is doing this one here. It's minus 3. Okay, so we see the range now. We see it's minus infinity 2 union 2 plus infinity, but we want to prove it. Okay, so this is giving us a big picture of the range, but let's prove it. We have two cases. Either we are here when x is bigger than 1. So remember, we have to write our function in this manner to make it easier for us. Okay, so remember, when x is bigger than 1, we are in this region. When x is less than 1, we are here. So first case, x is bigger than 1. So if x is bigger than 1, okay, we have x minus 1 is strictly bigger than 0. When we flip this one, when we inverse this one, we're going to have 1 over x minus 1 is still bigger than 0. Okay, if we multiply by 5, we still have 5 over x minus 1 bigger than 0. Why? Because 5 is positive. Now we add 2 to both sides. We have 2 plus 5 over x minus 1 is bigger than 2. And what's this one? It's just 2x plus 3 over x minus 1, which is f of x, which is y. So this one is telling us if x is bigger than 1, y is in this domain, 2 plus infinity. Okay, now let's see when x is less than 1. So if x is less than 1, okay, then x minus 1 is still less than 0. Okay, and when we flip it, it's still negative, so we still have x minus 1 less than 0. If we multiply by 5, we still have 5 over x minus 1 less than 0. Adding 2 to both sides, okay, we have 2 plus 5 over x minus 1 is less than 2. That means y is less than 2. Okay, that means our f is in this interval for x. When x is in this interval, minus infinity 1, y is minus infinity 2. That means the range of this function is for x, when x is positive, its y is here. When x is bigger than 1, y in here. When x is less than 1, y in here. So in general, for any x, the range is minus infinity 2 union 2 plus infinity. Okay, so this is the range. Okay, why is it not equal to 2? We will see why. Because the limit, we get close to 2, but we never touch 2. Assume now that we reach 2. That means 2x plus 3 over x minus 1 equals 2. Okay? And since this one is different from 0, let's multiply by x minus 1. So we get 2x minus 3 is equal to 2x minus 1. Okay? It's equal to x minus 3 to x minus 2. Now 2x we can cancel by it, and we get minus 3 is equal to minus 2. This can never happen. That means this one is always different from 2. That's why we don't reach this 2. Okay, we get close to it, but we would never reach it. When x is bigger than 1, we are above this line, this asymptote. It's called asymptote. Y equals 2. When x is less than 1, we are beneath it, but we will never be able to reach it. Okay? So this is how we do this one using algebra. We try to see where we are, and we try to find the values that are bigger or smaller than the value that we want to find. Okay, anyways, the range in this case is minus infinity 2 union 2 plus infinity. Okay, you can use the calculator and see that you will get this, our sum graph like this. Okay, with x equals 1 as the value of the domain that we don't get close to, that we reject, because we don't want to divide by 1. And 2 is the limit from the right side and the left side of the big numbers. Okay, this is how we do how we find the range of functions.